So back to cover some more stuff with trees. We've got a few theorems that we should cover from 8.2 and 8.3. One is that every tree has at least two vertices of degree 1. Here we're not counting this super trivial tree. So every vertex or every tree has at least, so except for this guy, has at least two vertices of degree 1. So you can look at it here, and then if I want to build this out, this would be my most basic tree that counts. Then I would go here, maybe I'll go here, maybe I'll go here and here, here, here. Every time that I grow this process out, then I either create a wholly new degree 2 or degree 1 vertex, or I will replace my old degree 1 vertex with a new degree 1 vertex. And we can obtain any tree by using this, what's called tree growing method, of basically you start with this guy and then you decide where you want to add vertices, or where you want to add edges and vertices. We sometimes call vertices of degree 1 leaves, because if you think of it as a tree with like this guy, bam, 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 you can think of them as tiny branches or leaves popping off of my main tree. Okay, so this is called a tree growing process. And if we want, we can start all the way from here, this most trivial tree. And then basically we create a new node, and then we pick which pre-existing node we want to connect it to. And we can only connect it to 1, because otherwise we will create a path. If we connect it to 2, we'll create a path. So we only pick 1. So here, and then let's say I put another one here, and then I can connect it to that guy, and then here I'll connect it to that guy, and here I'll decide, I'll go with this guy, and here, let's go here. And I can just keep on building these guys out. I can build out any tree using this method. And something to note here is that if I have n vertices, then I will have n minus 1 edges. And you can do this by induction. So you can say, because any tree can be built out like this, I can start off with this most trivial tree right here. And here I have 1 vertex and n1 minus 1 edges. So my base case holds. And then assume that I have n minus 1 edges for n vertices. And then I create 1 new vertex. So I create 1 more, and then I create 1 edge to connect it to my already existing tree. So by that process, I then have n edges and n plus 1 vertices. So that still holds. The last thing we're gonna say without Cayley's theorem, without proving it, is on a graph of so there are n to the n minus 2 trees with n vertices. And this is actually pretty complicated to prove, so we won't bother with it. But it is a noteworthy, interesting fact. So